I think we can start. Good morning. Um, my name is Michał Łusiak. I came here from Sweden, although it's a little bit complicated story. I really like this picture. This is a picture from International Space Station, and it shows my both current homes right now. We're somewhere around here, and I originally come from here, from northern Poland, and now I live in southern Sweden, which some people say is technically Denmark, but yeah. I work for this company. We're a consultancy focused mostly on .NET projects and also web projects. We also like to say that we create value by sharing knowledge, and we try to not only be like consultants hired by hours, but also like consultants that we like help our clients reach their goals and share our knowledge with them and organize knowledge activities and so on. We're mostly based in Sweden. If you came here because you heard something about bacon, that's the wrong talk. We're gonna talk about beacons. And beacons are small Bluetooth low energy devices that you can use to add physical context to your mobile applications. How many of you have do anything with beacons so far? Okay, how many of you know what beacons are? All right, cool. I've seen this before when I did this talk 2 weeks ago, so I changed it a little bit, and it's much more about beacons, much less about Windows, so you get a grasp of what they are and how you can use them. So let's roll back a little bit and talk about Bluetooth Low Energy first. Bluetooth Low Energy is also like marketed as Bluetooth Smart, and it's part of Bluetooth 4.0 specification. And it's not your mother's Bluetooth that you have to pair, that was very slow and has very low range. Bluetooth Low Energy works more about on a basis of broadcasting. So there's one device that's broadcasting, and there are other that can reach out to them. There is also like sense of pairing, and you can also do it, and you have GATT services like with normal Bluetooth. But we're gonna focus more on broadcasting part of Bluetooth Low Energy here today. And technically, I saw in specification that they said it has range up to 100 meters. My own experience says it's more about 70 or even 50 in closed spaces. It used the same frequency as normal Bluetooth, also as the Wi-Fi and the microwaves. And the reason microwaves use them is because water resonates at 2.4 megahertz or gigahertz. Gigahertz, yeah. Thank you. Gigahertz. And this causes some problems with beacons because bottles of water like disturb the signal. And humans are big walking bottles of water, if you look at it. So they kinda there will be some problem with beacons with very crowded spaces. Yeah, so let's go to beacons. They were like the technology like of Bluetooth Low Energy was there a couple years ago already, or even more. It was like Bluetooth Low Energy was co-invented with Nokia and a few other companies, and but it got really much more traction when Apple came with something they called iBeacon, which is nothing else than just specification how the packets look like and how they should be interpreted. And as I said, you don't really have to pair with those beacons, and primarily what they do, they just broadcast few bytes of data. And what you do with this data is up to you. So, so they cannot track people, but you can make app, like use the data within your app to track what people do. So, for example, you set up in space like this, like 4 or 6 beacons, and they broadcast some data, basically identifier. And your app is aware where those identifiers are physically located because you deployed them by yourself. and based on those like signals, you can triangulate and provide indoor location about the place, or you can provide information that I'm close to stage and display some information based on that, and so on. Yeah, they can also broadcast additional data. This really depends what producer put in there. For example, those are my favorites. They were made in Poland and they were pretty quick to market. They have temperature sensor and also accelerometer, and yeah, so basically they know if they're in the move, for example, or how hot it is. And they have another feature because you can like switch off them by turning them upside down for saving battery, for example. You can turn it off this, but it's quite useful if you do it for deployment and you just don't use them all the time. Yeah, they can also be updated over the air because they can receive some data. We'll talk more about inputting data to beacons later because there are some other possibilities. And they usually battery powered, although that's not the case. And they could be much smaller if not the battery. Usually battery determines how big they are. Those batteries, again, theoretically are for 2 years. I managed to run them down in a few months, so I have to like open up and switch the battery. But they come in very many form factors. There are like many producers, and they made them in a lot of shapes. They're different sizes. There are beacons that are like socket powered, so you connect them to electrical sockets, and you don't need to care about battery. There are USB dongles that you connect into speed. There are key rings, and so on. I'm gonna now play a short video from a producer of those beacons that they explain few use cases, how you can use them in real life. So let's go.
Smart beacons present relevant information to your device based on the context of where you are. Now in Android and iOS 7, your device scans for any nearby beacons in the background as you move around. And when you want info about something you're near, it's ready to swipe on your notification screen. So if you take out your phone as you pass a new restaurant, you can see their lunch specials or menu reviews. Since your phone knows that you just arrived at the table with the red beacon, the menu will be ready when you pick up your phone. So if you're in a hurry, you can send your order straight to the kitchen. You can have beacons at home too. So if your context is the kitchen and you're near the fridge, your shopping list will be ready and waiting when you look at your phone. And then when you walk by the beacon in the dairy aisle, your phone can give you a reminder to make sure you don't forget to pick up milk. And because the range awareness for beacons is sensitive down to a few inches, it can tell what you're closest to, or what product you pick up. So when you look at your phone, it'll already show product information, or let you know if your size is in stock, or let you see what other colors are available. And then you can order it right from your phone. And if you've been at the restaurant for a while, your phone will be ready if you want to order another drink or pay the check with the push of a button. Your phone is always with you. Smart beacons, give it some context.
Yeah, this guy didn't pay me for that. I just really like their product, so just a disclaimer. So let's now move to a little bit to technicalities and what exactly is transmitted and what use you can make of it. That's how iBeacon format a packet looks like. It's I think it's around 26 bytes or something like that. We go through all of them. Basically, first two are just indicator. It's Apple manufacturer ID. It's like normal in the beacon standard that you have manufacturer ID and some flags on the first 2 bytes. Then you go to what type of data you have and how long is it, and those things are fixed for iBeacons. Then you have UUID, which is like identifier, and then you have 2 other identifier, major and minor. So this is like what you're gonna use mostly with the iBeacons. You will use those 3 identifiers. For example, let's say you run a cafe in Oslo that's part of a bigger chain. So probably you'll have the UUID for your whole chain, like I don't know, NDC coffee. And then you'll have a first major ID for coffee house located at Spectrum, and some beacon located at one similar space will use some minor ID. Or you can use some other ID. Basically, those like 3 identifiers that up to you to use. And how you interpret them, it's pretty much up to you. Those are the one case I show is just one of the suggestion most commonly suggested. Yeah, and as I said, based on this part, your app can, I received this ID, which means the person using the app is near this place. Let's show them this notification or this context or something else. And the last part is TX, which is measured power. So device send also information with how much power they're broadcasting. Because thanks to that, you can calculate actually how close you're to the beacon. Because you can know you're somewhere within 50 meters of beacon, or 30 or 70, depending on the power settings. But it's usually not enough information for you to give any relevant context. We also want to know how close we are usually. And the other thing you know, like when you receive the packet, your device will show you how strong was the signal you received. So you have 2 information: how strong signal should be 1 meter from the device, and how strong you received that. And based on that and some math, you can figure out how far you're like. But I'll show you later. That's a little bit shaky, but that's the basic math for that. So basically, RSSI is this received signal. That's the formula for that, and N is a constant you use. 2 is usually how you use it in empty spaces. Like I would consider this pretty much empty space. You'll add. I think you have to bump it up higher. Yeah, it makes sense. To if you have like more abstraction, it's a lot of like trying and failing, because you can't really figure out what will bring how much distortion. So you probably have to, like, when you like deploy beacons into space, you put them, you have some idea how they should be, and then just adapt slowly to make better solution. Yeah, D is this distance in meters. So when you like turn around this formula, you get the formula for distance in meters. And also what I mentioned, if you have like more beacons in space, technically 3 is enough to do triangulation, as the name suggests. 4 or more is better, and the bigger the space, the more beacons you'll need to like cover the area to have a good precision of in their location. Now let's talk about the other solution or implementation. It's Google's Eddystone that came last year as a response to Apple's iBeacons, and they have more frame time. So you don't only have like one identifier type, the one iBeacon said, but you have a few other types of data you can broadcast. This one is really cool because you don't really need app for that. You just have broadcasting URL. So using iBeacons force your customer to have your app, for example, for your cafe. But what if you don't have they don't have those apps installed? So Google came with that, which is broadcasting URLs, and it also ties to their concept of physical web that we have also internet surrounding us. So let's say you come near your cafe, you don't get some random notifications that your phone doesn't really understand, so you wouldn't even get them. But you get pop-up with URL, and this works fine on Androids. And what they did on Apple is really smart, because they put it in all their applications. So if you have Google Maps, Google Chrome, Google anything on your iPhone, you'll get that too, which is pretty sneaky, but I like that. There's also Eddystone UID, which is the same concept as iBeacon. The format is slightly different because they have 2 levels of identifiers, but the idea is the same. So, And there is telemetry, which allows you to do few things. First is like you can have packets that send information about health of your beacons, which makes like fleet management easier. Because it's all fun when you have to like deal with 3 or 2 beacons in your room, but if you deploy 6,000 beacons to the airport, it's not that fun to actually maintain those. And they also send like some beacons have additional sensors. I mentioned that. So those packets also used to send information from those sensors, which makes much easier available than actually have to physically connect them and get those sensor data to GATT services, because that's how it works with Apple iBeacons. And right now I think it's good. There is some competition, and there are a few other proprietary packets for beacons. And I think like Apple will probably follow with URL format and so on, which I think it's good. Example application that I've seen done to use iBeacons. It's mostly like museums, just like indoor location or showing some information about what you're actually seeing, getting links and so on. But a very cool application I saw was a guide for visually impaired people to go around museum and like telling them what they're seeing and what they can experience. Retail spaces is pretty big because there's a lot of money there. So retailers would be really happy to know where they actually spend most of the time in the shop and so on. This is really like, I think it's not really good for customers. I mean, who would like to be tracked? So the business models here should probably include some gratification for people also that they're using the app. So there are some coupons and so on. Airports are pretty big in this. I know like Heathrow have been spiked with beacons, and British Airways is using them in their apps. And there are many other airports that are trying out with this. Also stadiums. I know that Barcelona Stadium in Barcelona is also full of beacons. They actually posted a blog post yesterday about Eddystone, the producer of the beacons. It's really interesting because they were also telling a lot about issues they have with placing beacons on different heights and so on. So public transport is something I've been working with recently. So ideas like you get to the bus and you get automatically started your trip, and when you get out of bus, you get your bus trip stopped and you get charged automatically and so on. So things like that. Also, I heard about some uses in healthcare. So I know there are some beacons in rooms of patients, and when doctors run around, they get information that something is wrong and so on. That's connected. It's really experimental, and didn't see like real life application of this, but I've seen some demos of that, and it's also probably interesting. And home automation is the one that was example, and that's people who are like nerds in IoT. That's what first they do. They spike their homes with Arduinos and cables and stuff, and they have their coffee pots connected. I haven't seen anything that was really sensible, but there are a few things fun you can do. For example, a lot of those smart light bulbs can connect with STMode and give you some things working on together. So, or with other beacons too. And I also told about like inputting data and basically custom data for beacons. So as I mentioned, there are some ways that you can like connect over the air to beacons and get the data from sensors. And there are some custom SDKs that makes it harder to do on different platforms. It's all fine and dandy if you're on Android and or iOS, but then things get slightly complicated. Like this one, beacons, that's something we've been working on last month, and that they have GPIO input, and you can send data over UART and create own packages. So pretty much we have solution that sends custom packages to our application, and it's based on some external factor from some external device it's connected to. It's one used in the actually public transport area. So the idea is that the beacon is connected to bus, but we simulate it with or to the train, but we simulate it with Raspberry Pi for now. And the client tried to use location with GPS, but it didn't work well in like big cities with skyscrapers and underground. But their trains have the data where they are based on some other things, and they want to connect those beacons to the trains or buses in the future, and just send the information about where you are and some other like messages, for example, about traffic obstructions and so on. So that's an interesting concept. And there are also ways to manage your fleet through fleet of beacons through cloud services. That's also one sneaky thing that's been done, because let's assume you have like beacons deployed all over some airport. You don't really want to go like physically within 1 or 50 meters to every one of it just to update them. So what can do, you can set the updates or some settings changes in the cloud, and then everybody who actually use app that's based on SDK of a beacon vendor or use their apps will basically be used as a way to carry up the updates. So it's like very distributed way of use your customers to update your beacons. Also very sneaky. Also I like it very much. So yeah, let's move to a main topic of today, which is beacons and Windows Phone. I've been using Windows Phone for 3 years now, and I'm also using iOS for some time. And when I first like heard about beacons, I was really like excited. Okay, let's bring it somehow to Windows, because it should be easy, and it wasn't, because first of all, none of the major vendors officially support Windows Phone. I mean, why would they? It's like so so small market, and but the hardware was there. Like all higher end Lumias had the radios that supported Bluetooth Low Energy. After all, it was Nokia's invention, so why wouldn't they put it in? The problem was software, because Windows 8 on computers has some ways to deal with Bluetooth 4.0, and like with much of a pain, you can actually do something with beacons. You could receive those signals, and it was very low level talking to hardware pretty much. With Windows 10, but there was like no support on like phones, because there was some difference between APIs on Windows 8. With Windows 10, the APIs are consistent, and there supports Bluetooth Low Energy on all devices, and they also specifically support Bluetooth advertisement packets, which is what we exactly want, which makes things a lot easier. So when you start working with beacons and you start your Windows Phone project, very important is to manage to like tick capability Bluetooth, because without it nothing will work, and you won't know why actually you don't receive any signals. So that's very common mistake, and very important to turn on Bluetooth on your phone and turn Bluetooth in your capabilities of application. And the way you do it these days is you have a Bluetooth advertisement watcher. You set some filters. So here I set up a manufacturer ID for Apple, and some like low and high values for when I consider beacon to be in range. Those values are between -127 to around +16. So basically, when your beacon is touching your phone, it's gonna be very like slightly over 0, Minus 127, it usually means that the packet was wrongly formatted. That's when you get this number. So that's the range I usually use to have like when my beacons are getting into proximity and getting out of proximity. And then you have like time, so when you don't see the beacons for like 2 seconds, you consider it like the watcher will like stop show it as visible, and then it will pop up again. You'll see it again. Okay, I'll try to connect my screen and see so what we can see. Oh. I want this. I want this. Yeah. So that's the application that's coming from a sample, Universal Windows Platform sample. It's on GitHub, full open source. So I'll link that in the presentation, so you can use those examples to start playing with the beacons. I'm gonna run now Watcher that will start getting information, but my beacons I'll switch up, so I'll switch them on and hopefully we start seeing something coming in. Oh yes. So you can see like information. Type is a type of connection. This is like Bluetooth thingy. Basically, we're not gonna bother about this. And do you see those RSSIs going, which is like the signal with how much strength we received the beacons. And you can see it shakes a lot because it really depends a lot of features. I have some electronics here around that disturbs that. I'm a bottle of water, I disturbs that too. So what you're gonna do, probably what you would like to do in real life is probably do some smoothing over time. So do like average over last second or something like that. So you don't get like this data very chaotic and spiking, but a bit smoothened. What's going on? Just want to show you something else, but it doesn't cooperate with me. Let's try again. Okay, so I just have only one beacon going on, sending messages. And RSSI are on the levels like 60 or minus 27 if there's some problem with the... So yeah, you can see it's 60, 70. There's I see with Windows Phone especially, there's a lot of packages like with minus 127, like it has some problem parsing it. I don't know, it's like problem of software or quality of the radio and so on. But in my solution, I just try to filter them out because there's usually just rubbish data. So like when I put it a little bit more far away, you should probably get worse reading, but now it's stopped. Yeah. It's really... Yeah, it's that now. Wonder why. Let's try with another one. So yeah, as you can see, it's not always very reliable with Windows Phone for some reason. We'll get back to this later. Sorry for that. Should be fine now. Yeah. So that's it usually looks like, and when you do something more interesting, like we have like full-blown Bluetooth device in this phone, so we can also transmit Bluetooth. So if we know how the package look like, can we fake the beacon? And that's the code that pretty much does it. I put in the data the usual package that's used by this company, by Eddystone. So it should show up in their app, and I'm gonna try it out. And also I put like the last bytes are minor ID and major ID, and also some power. So I put minor and major ID to 30 and 37. So hopefully we'll see them on the iPhone app looking like that. So I'm just gonna switch to the my iPhone and show the Eddystone app that shows their beacons, and hopefully I will see my spoofed beacon. I first fire it up. So yeah, should be running right now. So yeah, so I have 4 beacons on the screen, but only 3 that are like legitimate estimates. So let's them put far away, so I know which one is the one that I actually created. Yeah, you can see it slowly. You can see it has some slow updates, so you have to also include that in your application, that the updates will be. You won't see instantly that beacon went far away. Went beacon far away. There is some one even went blank because I switched away. But I think this is the one that I need to do with my finger. That I found, which also shows that I cannot connect to Eddystone Cloud because they don't really recognize this as their own beacon, even though I'm faking it. And there's major and minor 1337, which I set up in the bytes. So yeah, you can fake beacons, which like brings some security considerations, but I'll get to that a little bit later. Let's get back to our presentation. Hopefully, nope. Yeah, perfect. Yeah. So what I did is like right now it's a lot of pain to unpack those packets, because you still get raw advertisement packets, which is like 26 bytes. So I started doing some small library that will make it easier. I call it SMOKEY Beacon. It's already in very alpha stage on GitHub. So basically I provide the watcher configuration this way. I put it on for the demo purpose hard-coded, but there are some options right now. But this is basically configuration you need to listen for beacons that are iBeacons. And I also like add some like structures. You have objects with a UID, major, minor, calculating distance, and so on. And that's the way you listen for beacons, pretty much. When in your view in a Windows Phone, you start the watcher, you start the discovery, and then just add the event handler. So on every Bluetooth advertisement, you fire up events, and yeah, you get beacons listed. So I made very simple demo application that lists the beacons going around. So I'll show it to you now. Just kill this because I had problems when testing with demo because I technically connected to beacon that was my phone and it blocked any communication because now it's like very occupied to talk with my iPhone pretending it's beacon. So demo didn't work, but hopefully when I kill the app this should work. So let's see. I'll switch the screen again. Yep. And fire up the other range. And this app shows beacons that we see in range. I'll bring them closer. And, we got all three. And on the left there's a minor and a major ID. On the right you have received RSSI and the distance I calculated. So right now they show, for example, that they're around 1 meter when there's no 127, no, 60 centimeters and so on. And so you can see it's like the formula I use, it's probably like I should probably adjust the constant that was there to be more reflecting the environment that's in this room. And as you can see, it's also very jumpy. So as I said, you should really provide some smoothing, and that's one of the plans I have for this library, to like make those beacons using from Windows Phone painless. So we like I want to go like two ways. One way is you have full control, so you can basically do the smoothing yourself if you wish to, provide your own formula for distance and so on, and like full automatic. So basically give me those beacons and how far away they are with all the stuff. Hopefully this will evolve, although as I said it's more of a fun project to actually prove something, because Windows Phone is not growing in popularity anymore. I think it's going the other way around. It's interesting what Microsoft are gonna do with this. I think the Lumia line is slowly gonna die, and maybe they invest in Surface more, so we'll see more Surface phones. So maybe there's still hope for Windows Phone. We'll see. So yeah, let's move forward a bit. I'll get back to our presentation. Cool. Okay. So there are some security implications, as I mentioned. Like the problem is that let's say you don't like your competition and you know they have beacons set up in their store. You can put your own beacon with the same UID, transmitting with very, very high power, to overrun their beacons and send some other information that's maybe come to us, we have better prices or stuff like that. And that's really bad. So beacon providers came with several ways to solve it. And for example, one of them is a secure UID. So the way you act and work with beacons through their SDK is that you still use the same UID, so you know that's which beacons you're talking about. But what they do, they actually algorithmically switch the UID randomly every some time, and your app also is aware because the SDK use the same algorithm for that. The problem with that is that you basically render those beacons unusable without their SDK, and this will prove problems for using them with Windows Phone, because right now the way you use it, we just use the official advertisement packet and non-official APIs. The good side is a lot of them put their libraries in on the internet, and they're in the Java, and the Java, because for Android, which means it's easy to see the code by decompiling them, which it's probably not very. I don't say you should do this because it's probably on the gray side of legality, but that's the way you can see how they do those algorithms. And the other way is probably work with those suppliers to have a working solution with them. So I'm because the one of the vendors got interested that I'm doing this Windows Phone application, so we'll probably do the full thing for them, which is cool, and maybe we'll have also those security features. But yeah, the implication is that usually when somebody enables this secure UID or another way of securing those beacons, it's not gonna be easy to use them the way they were designed, so just reading the UUIDs. And because this wasn't a very secure solution, and they realized that very quickly that it's probably not going to work well. There are probably going to be some other ways of securing them, so we'll see. So for example, with those beacons, again, I talk about them a lot because I was working with them for 2 years, so I have the most experience with them. They have this cloud service that if you want to change any settings within them, you have to actually log into your cloud account. So you have to be logged into cloud account in their application, and then you can update the beacons, even though technically you don't really need to do it, but they have security measures put in that do it. Okay, so there are some code repositories I mentioned. There is Microsoft Windows Universal Platform samples. That's where I took the first demo. They're very useful to like play around with them. You can just change things and fire up, and you have some things working. There's my library, and last week I discovered there's some other library that also helps to dealing with beacons on a Windows Phone. And this is much more mature and complete, so I'll link that here. You can also use that too. Yeah, and that's all from me. Thank you for coming, and if you have questions, I'll gladly take them. And yeah.
How is the problem of updating these beacons in a large set of addresses these days? You need to make beacons somehow listen to your new firmware. How does that happen in airports or situations?
Like, so you mean like updating because you want to change some
UUID, for example,
yeah.
or with major version, for example.
Yeah. So yeah, the problem is that usually you have to do it manually. But as I said, like for example, ST-mode D-Link is with that you can change them in a cloud. I think I can show you my cloud account. How does it look like? Oh, I didn't connect to internet. I'll just quickly share connection from my phone. Yeah, and you can connect through the cloud and then set up all the settings for the separate beacons, and then they will be updated over the air while your phone is closed there, or some other person using their app. So you can do it like no. You can use people to actually update your beacons. You just have to.
So does ST-mode beacons, do they continually listen to these new firmware, or how does that work?
So I think the way it works, they are broadcasting, and when your phone that you used to update will see the broadcasting, they can send request to connect to GATT service.
Okay.
Yeah, and that's how you.
So I saw that all of these advertisements, daily advertisements, were non-connectable advertisements. So I was wondering how you actually connect to them.
Yeah, because those are the packets that I was reading too, and there's like those what we seen was just packets, and they're probably sending some other packets also, like because it's Bluetooth. And I was just looking for those advertisement packets. So those are my beacons I have connected, and I can change settings here. Have information of battery. I don't have any analytics set up, so I don't see it. But when you have like your beacons set up to send telemetry, then also other people will receive them and just send up to the cloud. So yeah, I can edit settings. So for example, change name, change minor, turn on security ID, and so on. So and when I save those changes, they will be somehow populated to my phone, probably very quickly because my phone running up is very quickly to the beacon. But that's how it works. Okay. There's one more thing. There are two of my colleagues speaking from my company. Carl Henrik is on the next slot, and also today evening and tomorrow morning. He's talking mostly about IoT. And there is Enrico on Friday. He will talk about what you can do with Git that you can't do with GUI, but you can do with command line. Enrico is really hardcore Git guy, so if you're interested, I also suggest you that. So, thank you for coming. Please vote and have a great conference.